Let's take this question from previous JEE Advanced. F 0, 1 maps to R with a function defined as fx equal to box 4x into x minus 1 by 4 square into x minus half. Now we need to check about the continuity and the differentiability of the function. So if we want to check the continuity and differentiability, let me first draw the graph of the function, say gx equal to the polynomial x minus 1 by 4 square into x minus 1 by 2. If we only concentrate on this polynomial, you can see that 1 by 4 is repeating 2 times as a root and 1 by 2 is a single root of the polynomial. So we can draw the graph of the polynomial something like this. This is going to be 1 by 4 where it will touch the x-axis because there is a repeated root at 1 by 4 and 1 by 2 is a single root. So 1 by 2 is here and say x equal to 0 is here, domain is 0 to 1, and one more point let us take is 3 by 4. Now we'll analyze for the function fx. Fx is nothing but box of 4x into gx. Box of 4x into gx. As you know that box of 4x will be integers in different domain. In different interval this will be an integer. So I am practically multiplying the function gx with different integers. Okay. So let us break down from 0 to 1 by 4 what is happening. From 0 to 1 by 4 what is the value of box 4x? Box 4x will be 0, right? Between 0 to 1 by 4 box 4x is 0. So then 0 into gx means function will be totally 0. So fx graph will be 0 between 0 to 1 by 4. So fx will be 0 between 0 to 1 by 4. Next, 1 by 4 to 1 by 2. 1 by 4 to 1 by 2, what is happening? For 1 by 4 to 1 by 2 x value, 4x will lie between 1 to 2. 4x will lie between 1 to 2. So box value of 4x will be 1. Then 1 is getting multiplied with gx means the same graph of gx. So we'll continue the same graph of gx here for the function fx. So we'll just repeat the same graph. Next, 1 by 2 to 3 by 4. 1 by 2 to 3 by 4. 1 by 2 to 3 by 4, 4x lies between 2 to 3, box value will become 2, I am multiplying 2 with gx, I am multiplying 2 with gx means all this y value will become twice, so there will be sudden change in the slope, and all the function value will jump 2 times, okay, so it will be something like this. So it was following the graph and suddenly from here all the function value jumps 2 times. Okay. And then 3 by 4 to 1, 4x will lie between 3 to 4, box value will be 3, so 3 times gx means all function value will be now multiplied 3 times. So there will be sudden jump and the function value will become now 3 times. So this is the graph of the function fx. So clearly from the graph we can understand that here there is a jump discontinuity in the graph and here there is a sharp turn in the graph. So this particular point will be a sharp edge. This particular point is a sharp turn because gx, it was gx and suddenly from here it becomes 2 times gx. Suddenly the slope becomes 2 times and here there is a jump. And this is a jump in the graph of the function and this is a sharp turn in the graph of the function. Here this is a smooth graph. Here slope from the left hand side is 0 and slope from the right hand side is also 0. So this is the smooth point. So if we come to the option, first option, the function f is discontinuous exactly at 1 point. Yes, the function is discontinuous here at 1 point. So that is correct. There is exactly 1 point at which function f is continuous but not differentiable. This is the point x equal to half where function is continuous but it is not differentiable due to sharp turn. So option B is correct. Option C, the function is not differentiable at more than 3 points. How many non-differentiability? 1 non-differentiability, 2 non-differentiability. So this option is wrong. And finally option D is the minimum value of the function f is minus 1 by 512. What is the minimum value of the function within the domain 0 to 1? So the minimum value of the function is at 0, the function value is 1 by minus 1 by 32. At 0, a value is minus 1 by 32. Now, can this one be further below this particular point? So, we need to find out here what is the function value. Here, what is the function value? Because this may be a minimum value of the function, okay, between 1 by 4 to half. So, let us try to find the minimum value here between minus 1 by 4 to half. So, for x belongs to 1 by 4 to 1 by 4 to 1 by 2, within this I am getting a local minimum. What is this local minimum value? So what is the function? The function is fx equal to, what is the box 4x value here? Box 4x value here is 1. So the function will be fx equal to x minus 1 by 4 square into x minus 1 by 2. And I need to find out the minimum value of the function. Okay. So the minimum value will be achieved where the derivative must be equal to 0. So let us go for the derivative of the function. So f dash x is equal to 2 into x minus 1 by 4 into x minus 1 by 2 plus x minus 1 by 4 square. This is the derivative. So if I factorize x minus 1 by 4 common, it will be 2x minus 1 plus x minus 1 by 4. So derivative is becoming 0. We are getting 2 factor x minus 1 by 4 into 3x minus 5 by 4. So where the derivative is becoming 0? Derivative is becoming 0 at the roots of this equation f dash equal to 0 at x equal to 1 by 4 or x equal to 5 by 12. At x equal to 1 by 4 or x equal to 5 by 12. But our domain is 1 by 4 to 1 by 2 open interval. So we cannot take x equal to 1 by 4. We should take x equal to 5 by 12. At 5 by 12, what is the function value? So this point should be equal to 5 by 12. X equal to 5 by 12. What is the function value at 5 by 12? F 5 by 12 is equal to, substituting here, it will be 5 by 12 minus 1 by 4, that is 3 by 12 square into 5 by 12 minus half, that is 6 by 12. So this function value is equal to 1 by 6, that is 1 by 36 into minus 1 by 12. So that is minus 1 by 144 into 2. 432. So this is the minimum value of the function, minus 1 by 432, because it is less than minus 1 by 32. So minimum value of the function is not minus 1 by 5.2.